Welcome to this video about solving logarithmic equations and inequalities. Part 3 focuses on solving logarithmic equations. Our discussions on rewriting logarithm to its exponential form, properties of logarithm, and laws of logarithm is very useful in solving logarithmic equations. Now let us have your first example. You have the logarithm of x base 4 equals 2. To solve this equation, we need to find the value of the x. And as what you have observed, this logarithmic equation can be rewritten into its exponential form. Remember that in order for us to rewrite logarithm to its exponential form, the base of your logarithm becomes the base of your exponential. The x variable in your logarithm becomes the answer to your exponential, and the answer to your logarithm becomes the exponent to your exponential. So rewriting this logarithm to its exponential, we get 4 squared equals x. So in order for us to get the value of your x, we simply square your 4, so your x is equal to 16. Checking if your answer is correct, we substitute 16 to our logarithmic equation, so we have logarithm of 16 with base 4 equals 2. You can simply check if the answer is equal by using your calculator, but we can also solve it manually by rewriting this logarithm again to exponential. So in exponential form, we have the logarithm of, 4 raised to squared equals 16, and we all know that 4 raised to the second power is also 16. Since we have solved our logarithm, we can now conclude that x equals 16 or 16 is the solution to our logarithmic equation. Now let us go to your second example. You have the logarithm of the quantity 2x minus 1 base 3 equals 2. Again, we need to find the value of x. To find the value of your x, we need to rewrite first your expression into its exponential form. We get 3 squared equals 2x minus 1. 3 squared is equal to 9, so you have 9 is equal to 2x minus 1. Now, the next step is for us to combine the like terms. When you combine like terms and you need to find the value of your x, so we need to write your 2x to the left side of the equation. And this becomes negative 2x minus negative 9 minus 1. So you have negative 9 minus 1 is negative 10. So we have the negative 2x equals negative 10. To extract the value of x, we simply divide both sides by negative 2. So we have x is equal to 5. To check if our answer is correct, we simply substitute again our x value to our original logarithmic equation. So we have the logarithm of the quantity 2 times 5 minus 1 with base 3 equals 2. 2 times 5 is 10 minus 1, that is 9. So we get the logarithm of 9 base 3 equals 2. Rewriting this one into its exponential form, we have 3 squared equals 9, and we all know that 3 squared is also equal to 9. Since our equation is being satisfied, therefore we can conclude that x equals 5 is a solution to our logarithmic equation. Now let us have another example. You have the logarithm of the quantity x plus 1 base 2 plus the logarithm of x minus 1 base 2 equals 3. Observe that we are already using an addition to your logarithmic equation. And remember, class, that in our laws of logarithm, addition is equivalent to multiplication. So in order for us to solve this logarithmic equation, we need to rewrite this one into its exponential form and apply the first law of logarithm. Rewriting and applying the first law of logarithm, we get 2 cubed equals the quantity of x plus 1 times the quantity x minus 1. Remember that because we apply the first law of logarithm, your addition becomes now multiplication. And applying multiplication of binomials, you have x plus 1 times x minus 1. By using FOIL method, we get 2 cubed is equal to x times x, that is x squared. X times negative 1 becomes negative x. Positive 1 times x is equal to positive x. Positive 1 times negative 1 is equal to negative 1. Simplifying both sides of our equation, we have 2 cubed is equal to 8 equals, because this is negative x plus x, this will be cancelled, and what's left is x squared minus 1. Next step is to combine like terms. Combining like terms, we get a negative x squared equals negative 8 minus 1. And to get the positive value of your x, we multiply both sides by negative 1, and we have negative 1 times negative x squared equals negative 9. Negative 9 comes from negative 8 minus 1. Negative 9 times negative 1. So negative x times negative 1, we have x squared. Negative 9 times negative 1 is equal to 9. To extract the value of x, we take the square root of both sides of our equation. So you have the square root of x squared equals the square root of 9. Therefore, our x is equal to positive and negative 3. Now, let us check if our answer is correct or if we have an extraneous solution. When you say extraneous solution, meaning we have a values to your x that cannot solve to our logarithmic equation. So, checking for extraneous solution, we simply substitute the value of your x to our equation. First, we have x is equal to 3. So, you get the logarithm of the quantity 3 plus 1 base 2 plus the logarithm of 3 minus 1 base 2 equals 3. Performing the operation, we have the logarithm of 4 base 2 plus the logarithm of 2 base 2 equals 3. So, from the first law of logarithm, our addition becomes multiplication. So, we have the logarithm of 4 times 2 with base 2 equals 3. 4 times 2 is equal to 8. So, we get the logarithm of 8 base 2 equals 3. Rewriting this one into exponential, we have 2 cubed equals 8, and we all know that 2 cubed is equal 8. So, meaning we have satisfied our logarithmic equation, and x equals 3 is a solution to our equation. Now, let us check x equals a negative 3. Substituting, we get logarithm of the quantity negative 3 plus 1 base 2 plus the logarithm of the quantity negative 3 minus 1 base 2 equals 3. Performing the operation, negative 3 plus 1, this becomes negative 2. So we have the logarithm of negative 2 base 2 plus negative 3 minus 1, that is negative 4. So you have the logarithm of negative 4 base 2 equals 3. Recalling our logarithmic expression, logarithm of a base b equals c, a must always be positive. Looking back to our logarithmic equation, when we substitute negative 3 to our x, you have negative 2 and negative 4, which is the a part to your logarithm. Because the a part is negative, therefore, x equals negative 3 is an extraneous solution, or it cannot solve your logarithmic equation. Therefore, the solution to our equation is only x equals 3. Another example, you have the logarithm of the quantity x plus 25 base 3 minus the logarithm of the quantity x minus 1 base 3 equals 3. Observe that we are using another operation for your logarithm, that is subtraction. And in the law of logarithm, subtraction is equivalent to division. So applying second law of logarithm in our discussion, we have the logarithm of the quantity x plus 25 divided by the quantity x minus 1 base 3 equals 3. Next is to rewrite this expression into exponential form. We have 3 cubed equals the quantity x plus 25 all over the quantity x minus 1. 3 cubed is equal to 27, so we get 27 equals the quantity x plus 25 all over x minus 1. To simplify our expression, we will eliminate the rational expression in the right side of our equation, that is that is x plus 25 all over x minus 1. To eliminate its rational expression, we multiply both sides of our equation by the denominator x minus 1. So after multiplying, we get x minus 1 times 27, and on the right side, the remaining, or what have left, is x plus 25. Simplifying, we multiply 27 to the quantity x minus 1, we get 27 times x, you have 27x, and 27 times negative 1, you have minus 27, equals x plus 25. Combining like terms, we have 27x minus x equals 25 plus 27. Performing the operation 27x minus x, we get 26x equals 25 plus 27, we got 52. To get the value of your x, divide both sides by 26, x would be equals to 2. Now let us check if our answer is correct. We substitute our x, which is equal to 2, to our logarithmic equation. This becomes the logarithm of the quantity 2 plus 25 base 3 minus the logarithm of 2 minus 1 base 3 equals 3. So performing the operation, 2 plus 25 is equal to 27 and 2 minus 1 is equal to 1. So we get the logarithm of 27 base 3 minus the logarithm of 1 base 3 equals 3. Applying the second law of logarithm, we have the logarithm of 27 divided by 1 base 3 equals 3. 27 divided by 1 is 27, so we have the logarithm of 27 base 3 equals 3. Logarithm 27 base 3 equals 3 can be rewritten into its exponential form, which is 3 cubed equals 27. 3 cubed is equal to 27, so we got 27 equals 27. Since we have satisfied our logarithmic expression, this means that x equals 2 is a solution to our logarithmic equation. Now let us go to our last example. We have 2 logarithm of x equals logarithm of 2 plus the logarithm of the quantity 3x minus 4. We can solve this equation by applying the third law and the first law of logarithm. Applying the third law, your numerical coefficient 2 becomes the exponent to your logarithm, so we have the logarithm of x squared. Then applying the first law of logarithm, your addition becomes multiplication, so we have the logarithm of 2 times the quantity 3x minus 4. Now we can see that our logarithm has common bases. So since they have common bases, we can apply one-to-one property, disregard our logarithms, and bring down x squared equals 2 times the quantity of 3x minus 4. Performing the operation, 2 times 3x, we have 6x. 2 times negative 4, we have negative 8. So we get x squared equals 6x minus 8. Equating our equation into 0, this becomes x squared minus 6x plus 8 equals 0. To find the values of our x, we need to factor our quadratic equation. Factoring, we get x minus 4 times the quantity x minus 2. So we will equate our factors into 0. X minus 4 equals 0. X is equal to 4. X minus 2 equals 0. So we have x equals to 2. Now we have two values of our x. We need to check if these two values can solve our equations. So next is for us to check for extraneous solution. Again, extraneous solution is a solution that cannot solve our equation. So first, we will use our first value, that is 4. Substituting, we have 2 times the logarithm of 4 equals logarithm of 2 plus the logarithm of the quantity 3 times 4 minus 4. So performing our operation, 3 times 4, that is 12 minus 4, so that is 8. So you have the logarithm of 8. And applying our third law of logarithm, numerical coefficient becomes the exponent of our logarithm. So you have the logarithm of 4 squared equals the logarithm of 2 plus the logarithm of 8. Now we have an addition. Applying our first law, this becomes the logarithm of 4 squared, that is 16, equals the logarithm of 2 times 8. Our addition becomes multiplication. So you have the logarithm of 16 equals 2 times 8 is 16. So we have satisfied our logarithmic equation. Second, we have x minus 2. Substituting, you have 2 times the logarithm of 2 equals the logarithm of 2 plus the logarithm of the quantity 3 times 2 minus 4. Performing again, we have third law, our numerical coefficient becomes our exponent. 3 times 2, that is 6, minus 4, we have 2. So we have the logarithm of 2 squared equals the logarithm of 2 plus the logarithm of 2. Logarithm of 2 squared is equal to the logarithm of 4. Since this is addition, we apply multiplication from our first law, so we get the logarithm of 2 times 2. So we have the logarithm of 4 equals the logarithm of 4. Again, our logarithmic equation had been satisfied by x equals 2. Therefore, we have two solutions to our equation. X equals 4 and x equals 2. I hope you have learned from our video on how to solve logarithmic equations. Like and subscribe to my channel to be updated for the next upcoming videos. Thank you!